Okay, so today we're going to start with chapter 3, and we are starting on section 3.3, which is talking about the intercepts. So going back to what we were doing before spring break, where we started with the graphing, and I sent you guys an email if you needed a graphing calculator to install on your computer. So please make sure you contact me and let me know if you need that file. It was too big to upload in my math lab. All right, so first we're going to identify the intercepts. So remember that intercepts are where your graph crosses your x or y axis. So if I'm here, this is the x-intercept, and if I'm here, this is the y-intercept. So we're just going to identify them first. Think about where their location is, and when we talk about naming them, like if I'm starting at the origin and I go to the x-intercept, I went x units over, but I did not go up or down. And then if you're starting here at the origin and you go to the y-intercept, you did not move left or right, you only went y units. So, identifying the intercepts. So if we have this graph, y equals 4x minus 8, notice that this crosses the crosses the y-axis. And let me scroll down a little bit. So it crosses the y-axis here. So this is the y-intercept. And then it crosses the x-axis. And for some reason, okay, so let me move my dot. Okay, there we go. So the x-axis, it's crossing at 2, 0, and this is called your x-intercept. So pay attention to where the 0 is located because that's a common mistake to get backwards. So make sure you understand why it is 0. Okay, so here's some helpful hints. So if a graph crosses the x-axis at 2, 0 and the y-axis at 0, negative 8, then the x-intercept is 2, 0 and the y-intercept is 0, negative 8. Notice that for the x-intercept, the y value is 0, and for the y-intercept, the x value is 0. This is what I was saying, to make sure you pay attention on that, because it's very common to get them backwards and to mix them up. So you may do that at first, and just be cautious of your mistakes. Sometimes in mathematics, you may see, apparently I can't talk this morning, just the number negative 8 stated as the y-intercept and 2 stated as the x-intercept. So if they state that the y-intercept is negative 8, this is what they're referring to. So here are some examples. So if I look at this graph here, and I will change color since it's in blue. Let's go back to orange. So here it's crossing the x-axis here, it's crossing the x-axis here, and it's crossing the y-axis here. So there are 2 x-intercepts and there's 1 y-intercept. Don't get them backwards either, another common mistake to watch out for. In this graph, there is only an x-intercept. So if you do have a graph that only has 1 x-intercept, then it's going to be a vertical line. And just the same, I'll add an extra graph in here. Let's see, I want a line, and we will do this green one. So if I were to draw a line through here, then this would be my y-intercept at 0, negative 4, and this would be 2, 0. All right. So now we're going to use those intercepts to graph a linear equation. When you're working in my math lab and it tells you to graph an equation using the intercepts, they expect your answer to be the intercepts. So even if you create your table like we've been doing, where you find your x and your y's, and you've been choosing negative 1, 0, and 1 as your x values to find the y values, When they are specifically asking you to use your intercepts, then you're going to assign x as 0 and find y, then assign y 0 and find your x. So your table will look like this, and you are going to find those two values, and then you'll graph them. So finding x and y intercepts, it's really easy. If you're looking for the x-intercept, let y be 0. If you're looking for the y-intercept, let x be 0. So now we're going to graph 4 equals x minus 3y by finding and plotting its x-intercepts. So first we're going to write down our equation. So if I want to find the y-intercept, I'm going to let x be 0. So 4 equals 0 minus 3y. 4 equals negative 3y. And then we're going to divide by negative 3. So we get that y is 4 over negative 3, or negative 4/3. So that means if x is 0, then y is negative 4/3. In other words, if x is 0, my y-intercept is negative 4/3. So that's going to, when they talk about plotting, when it's fractions like this, it's a little harder to do, but if I'm not mistaken, I don't think in my math lab it's going to ask you to plot a fraction. It'll be a whole number. But just know fractions are still a possibility. So now we are going to let y be 0. So going back to my equation, what was it? 4 equals, let's see, let me do this. That way I don't make any or mistakes. I want to, okay, so I'm going to cut this, and then I'm going to go over here and paste it. So there we have our equation. So now we are going to let y be 0. So now we have 4 equals x minus 3, and this time y is 0. So 4 is equal to x minus 3 times 0 is 0, and x minus 0, if I have x and don't take anything, I still have x. So now x is 4. So now my point is 4, 0. So a while ago, x was 0 and it was negative 4/3. So this is my x-intercept. This is my y-intercept. So along with the intercepts, always find that third solution. So think back to your table, and this is just a checking point. So when x was 0, this was negative 4/3. When y was 0, this was 4. So now they're saying let y be 1. And go ahead and find that third point. Even though we don't graph it in my math lab, we're going to use it to check to see that we're on the graph. So I'm going to go back over here and put my equation. So now I've got 4 equals x minus 3 times 1. 4 equals x minus 3. So we're going to add 3 to both sides. 4 plus 3 is 7. So now x is 7 when y is 1. So I can graph using my intercepts as it's asking, and then I'm going to just double check that that point is actually on my graph. So go over here, and they graphed it for us. So notice it's a little below because negative 4/3 is negative 1 1/3. So negative 4/3 is equal to negative 1 1/3. So just a little under the negative 1. And then you have your x-intercept, and then they just double check that 7, 1 was on the line, and then they graphed it. So this is what the graph looks like for this equation. So now we're going to graph 2x equals y by finding and plotting its intercepts. So to find the y-intercept, let x be 0. So if x is 0, 2 times 0 is 0, so y is 0. So when x is 0, when x is 0, y is 0. So that's the origin. Well, what do you think is going to happen if they say let y be 0? So I got 2x equals 0. So I divide by 2. Remember, when you divide by 0 by 2, your answer is still going to be 0. So again, I did the equation and I have the same point. So since it's the same point, what do? Well, you're going to have to create the table and choose your other 2 points. So they're saying, so notice that anytime 0, 0 is a point of a graph, then it is an x-intercept and a y-intercept, because it's the only point that lies on both axes. Since we need at least 2 points to graph a line, we'll have to find at least one more point. So let x be 0. So we were working with 2x equals y. So 2 times 3 equals y. So our equation 2x equals y. So 6 is y. So we know in our table that 0, 0 was the answer 2 times. So now they're saying let x be 3. Well, when x is 3, y is 6. So now we have 2 points. And now they're saying let y be 4, because we need at least 3 points. So 2 times x equals 4. So we're going to divide both sides by 2. X equals 2. So now I have my x and y intercept, and then I have 2 additional points. So now plot all 3. So you can just choose which 2 if you wanted to graph these 2 and then check this one, or graph these 2, but make sure you're graphing this one because they specifically ask for your intercepts. So now we're going to graph vertical and horizontal lines. So do y'all remember in class that one day I talked about Vux, Hoy? So Vux, Hoy. We went over this on the Elmo that day. So remember that when you have an equation that is, or when you have a line that is vertical, so let's see, I'm just going to write this out. So when you have an equation that is vertical, it's going to say x equals some number, some constant. And Hoy is for horizontal. And you're going to have an equation that says y equals some constant. So we're going to graph those. These are the easiest ones, and they always trip everybody up because you expect them to be harder. When they're easy, let them be easy. So we're going to graph x equals -3. It can be written in the form of x equals 0 times y, meaning 0 times y is 0, and 0 cancels out. So any value we substitute for y, no matter what, because we're multiplying by 0, is going to give an x-coordinate of -3. And then the graph will be a vertical line, always, with no y-intercepts. So for example, you go, if it says x equals any number, in this case -3, go to the x-axis and find -3 and draw a vertical line through it. So this is the equation, x equals -3. It's just that straightforward. If you graph y equals +3, it can be written as y equals 0 times x. So no matter what value we choose for x, it's always going to be multiplied by 0, so it's going to cancel out. So now you go to your, since we're looking at y equals 3, you go to the y-axis, you find 3, and now you draw a horizontal line, Vux, Hoy. So when it says x equal, it's a vertical Vux, and when it says y equals, it's a horizontal Hoy. So vertical lines, so that's where they're getting the x equals c. C is the constant, it's a real number. So this is kind of, if you can memorize this, would be best. And that is it. So now we'll look at 3.4 next.